Hello everyone and welcome back to my channel. This is Yamaya's Learning Sessions. So today we are going to be working, or reworking I should say, from Quest Homework number 10. This is problem 15. Okay, so the problem says a cello string vibrates in its fundamental mode with a frequency of 178 1 per second. The vibrating segment is 100.3 centimeters long and has a mass of 1.28 grams. Find the tension in the string, and it wants the answer in units of newtons. Okay, so it gives us the frequency, which is 178. It gives us the length, which is 100.3 centimeters. It gives us the mass, which is 1.28 grams. And then I have the wavelength in my T-chart, which is 200.6. Now you might be wondering, well, it doesn't give us the wavelength in the problem. How are we supposed to know what the wavelength is? Good question. All you have to do is take the length, so in my case it's 100.3, and multiply that by 2, and that's going to give you your wavelength. So multiply your length by 2, that'll give you your wavelength, and then you can list it in your T-chart. Okay, are we ready? And okay, so let me explain the wavelength part. Okay, so imagine this is the string, right? Okay, and from here, right? From here to here, this is the wavelength, right? And let's see. I'm trying to do a nice picture, but it's not really working out for me so great. And here to here is the length, okay? So imagine here to here, right? And then here to here, you're just, this is such an ugly, I hope you are understanding this. You're basically just multiplying it by 2 because this part is the wavelength, right? So just multiply your length by 2, okay? And make sure to list everything in your T-chart so you can be organized, especially with one of these problems where they give several numbers, several values, different information. It's good to just kind of organize your information. Okay, so right off the bat, we need to convert some of these numbers. So we need to convert the centimeters to meters and the grams to kilograms. So do that real quick. So if I convert 100.3 centimeters, that gives us 1.003 meters. And then if I convert 200.6 centimeters, that gives us 2.006 meters. And then 1.28 grams gives us 0.00128 kilograms. Okay, just make sure your numbers are converted because then you're going to get the wrong answer into Quest. Okay, so we're going to be using these equations that we recently if you're in, that you should be learning right now, the transverse wave on a spring. So this is the equation we are going to be using to find our final answer. Velocity is equal to the square root times the force, velocity is equal to the square root of the force divided by mu, okay? And it asks us for the tension. So we're looking for tension, or the force, right? The tension force, of course. So this is our unknown F, right? So this is the equation we're going to be using. But you may realize, well, we don't have mu. It doesn't give us, right? It doesn't give us mu, and it doesn't give us the velocity either. So that's what we're going to have to find in order to being able to solve for the tension force. Okay, so in blue, let's solve for, actually no, we'll try the mu first. Okay, so we're going to solve for the mu first. Okay. We'll solve it down here, okay? So this equation, mu, is equal to the mass over the length. Now, I keep calling this mu, but this is actually called, in this case, linear density. So the linear density is equal to the mass divided by the length, and it'll give us 0.00128, right? Because we're taking this mass and we're dividing it by this length, which is 1.003, and that'll give us the linear density is equal to 0.0012. Okay? So we just found our mu, or our linear, I need to stop calling it mu. I get confused with it, but it's linear density. So we found our linear density, right? Sorry about that. And now we're going to find our velocity because we need the velocity in order to find the tension force. Okay. In blue, we're going to use the equation that keeps coming up. It's going to keep coming up. Velocity is equal to force times, velocity is equal to the frequency times the wavelength. So in this case, we have frequency, we have wavelength. All we're going to do is multiply those numbers. 178 times 2.006. And that'll give us the velocity is equal to 357.068. I'm sorry if it's kind of getting crowded over here. Okay, now we have our linear density and we also have our velocity. So now we can solve for the tension force, okay? We're going to plug it all into this equation that we're going to be using to solve for. So our velocity, which is 357.068, is equal to the square root of f divided by our linear density, which is 0.0012. Okay, now in order to get rid of the square root, we need to square it. So square it on both sides. Okay, and bring this down. 357.068 squared is equal to the tension force divided by 0.0012, which is our linear density. Okay, now we can cross multiply, right? So to make this to envision this better, I'm just going to put it over like this. We can cross multiply. Not going to do the whole butterfly thing because it'll mess it up, right? And make sure to square this. So in your calculator, you can just put 357.068 squared times 0.0012, or you can square that number and then take that squared number and multiply it by your linear density. It's up to you. Either way, it'll give us the force is equal to 162.7087. Okay? So this is our final answer. This is the number we're going to be putting into Quest. Reminder, always go out for decimal places when putting it into Quest because it's very picky and rather be safe than sorry, right? So recap what we just did. We found out that we needed to find the tension in the string. We listed all our information, the frequency, the length, the mass. We found the wavelength by multiplying the length by 2, right? Then we realized that we needed to use this equation. Velocity is equal to the square root of the force divided by the linear density. Then we figured out, well, we don't have the linear density and we don't have the velocity. So we found the linear density by using linear density is equal to mass over length. We found that. Then we said we need the velocity as well. So we said velocity is equal to force times wavelength. We found the velocity. Then we plugged everything in and we solved for the tension force. So our final answer is 162.7087. So I hope that this helped you a little bit and that you're able to solve with your numbers because, maybe you have different numbers than I do. And I would love any feedback in the comments below if you think I should do something better, something I need to improve on. It's always welcome. Any comments, questions, or concerns, of course. And thank you so much for taking your time out of the day to practice some physics. Have a beautiful and blessed day. Bye-bye.